in the last session, we had introduced the concept of imaginary numbers. Now let us go deep into understanding what imaginary numbers are. Now to start with, let us start with something slightly different, and then we'll slowly reach to the definition of imaginary numbers. Let's say you have a point source here. So that is your source of light. And there is an object which is trying to rotate in this direction. So this is a stick or an opaque object which can rotate around this point O. So OA can have different orientation at different point of time. Let us mark this as, let's say this is OA1, OA2, OA3, OA4 and so on. Now we have a screen here. The screen is supposed to capture the shadow created by the point source S. When it is in OA orientation, which is exactly aligning to the perpendicular that we can drop from the source of light onto the screen. At that point of time is very similar to, the concept is very similar to looking at your shadow during 12 o'clock, the midday, the noon. Now if we try to figure out the length of the shadow here, it will be exactly as the width of this object or the width of the stick. So that will be your length of your shadow. So let's say the length of shadow here is small s. Similarly, when it is in OA1, at OA1 or let's say at OA2, either of those, your shadow will be somewhere here. So you will have a shadow starting from this point all the way till this. So this will be the length of the shadow S1. For A2, it is further up here. This is S2. For A3, it is again very close to the be aligned with the perpendicular dropped from the point source to the screen. In this case, it is slightly off, so you will find a shadow that will be of length S3 and so on. For A4, I am not just going to do it again, it's a similar explanation. So now, if this object OA is rotating in this direction over time, and if I am just trying to record the length of shadow that I am being able to measure on the screen, then starting position, if it is OA, then S, the next shadow, if I am doing a sampling at OA1, it will be S1, S2, S3, S4 and so on, returning to S again, and it will go on. So this is a series. This is a set of numbers which denotes the variation of the length of the shadow. Now, how does that relate to imaginary numbers? Let us plot these on the real number line. This is 0.0. So we had a very small number s. It increased to S1, S2, S3 is again a shorter one, but as per our diagram, it is somewhere between S and S1. S3, S4, then to S and again coming back. So basically, you can see that your number series is oscillating between S to some extent and then coming back. So this set is basically trying to represent the rotation of the stick OA. So now we are clear that a set of real numbers can in fact represent the rotation of an object. Let us put this entire thing on a graph paper or a chart kind of notation. So let's say this point OA, this 0 is aligning with the center of the real axis line. So at some point of time, the stick was at this direction. Later it went up to OA1, it went up to OA2, it came to OA3, OA4 and so on. So it is moving on a direction like this. So how do we figure out how far this A2 is from the point O? As per the magnitude of OA2, the stick does not change in length. So OA1, OA2, all are same in terms of their magnitude. But as you can see, the effect of these on the real number line or on the screen changes. So what exactly happened here? If I draw a line OA2 here and drop a perpendicular from this on the real number line, it will be somewhere closer than the point A. The point A was here. It will be somewhere closer than the point, let's say it is A prime. Similar to that, if we take another axis which is perpendicular to the real number line and we try to drop a perpendicular on that, let's say that is B prime. In this case, the length of the shadow on the screen that we have been looking at so far, would be OA prime. And if there was another perpendicular light source somewhere around here, if we are looking at this, from this point onwards, we would have seen a shadow of OB prime. So from this direction we find OA prime, from this direction we find OB prime. What are OB primes and OA primes? OB prime and OA prime are the components of OA2. The mathematical way of looking at that is, since we know that here B prime and A2 are on a line which is perpendicular to this vertical axis, the vertical axis is perpendicular to the horizontal axis, so B prime A2 is a line parallel to OA. As you can clearly see, OA prime A2 B prime is a rectangle. So OB prime is equal to A2 A prime. So OB prime is equal to A2 A prime. Now, as per the Pythagoras formula, OA2 in magnitude will be equal to square root of OA prime square added with A2 A prime square, which is the same as OA prime square plus OB prime square. So basically OA2 is now divided into two mutually perpendicular components which result into OA2 as a vector. Now we move from scalar to vector. We are introducing the concept or the idea of direction and rotation. Let us say this angle is denoted by a symbol called theta. So angle A to OA prime is equal to angle theta. In that case, the way we write OA2 is equal to its component on the x-axis, which is OA prime, plus its component on the y-axis, the perpendicular axis, which is OB prime. But if you just write it like that, it really doesn't add up, right? Because OA prime plus OB prime is not actually OA2 in terms of the scalar magnitude. The way we do is we mark it with a variable or symbol I. This I indicates that OB prime is at an angle of 90 degree from OA prime. So this introduces the concept of rotation. So I is simply a way of telling that this component of OA2 is basically at an angle of 90 degree, positive 90 degree, at an angle of plus 90 degree with the base component, or the real, the component on the real axis, OA prime. So I, the imaginary number, is introduced here. So I, or this imaginary number, is nothing but indicating an angular rotation of 90 degrees. So I, remember this, I, this imaginary number, is equivalent to 90 degree rotation. Now, why do we call it as an imaginary number? First of all, we name it as a number because we are multiplying that with another number and resulting in a different number. So somewhere we are using that in mathematical calculations involving numbers. So it is easier to denote that as something, some member of the number family. So we call it a number. Now, why is it imaginary? Because it is not really a number. I is just a concept. I just tells you there is a 90 degree rotation. So that's where the name comes from. It is an imaginary number because it deals with numbers, but it itself is a concept that shows that there are two different components of a particular vector at 90 degree angle to each other. Alright, so this leads to our next question. If I is an imaginary number, what is the value of I? Can I introduce the concept of rotation with multiplication? Yes, I can. Let me explain to you how it works. So, let's say you had this this scalar OA. What happens when you multiply that by minus 1? It becomes minus OA. Now, if I try to represent these two numbers, OA and minus OA, onto the number line, it looks something like this. I do not go by this rotation of minus OA. It's actually a scalar quantity that I'm talking about. Just for the sake of explanation, I wrote it this way. So this was our 0 point. OA was somewhere here. So let's say OA was 3 centimeters. So when you multiply by minus 1, it becomes minus 3 centimeters. So basically, we went from here to here. OA was 3 centimeters. OA double prime is what represents minus 3 centimeters. That means any number, let's say x multiplied by minus 1 is equivalent to 180 degree rotation. OA turned 180 degrees to reach OA double prime. Now, as we know that from the previous diagram, OA prime, OA2, OB prime, from this previous diagram, we know that I indicates a rotation of 90 degrees. So, if multiplying by I indicates a rotation of 90 degrees, then once I am multiplied by I, if I multiply the same number by I again, so if I multiply by I again, definitely it is 90 degree plus 90 degree rotation, which is a 180 degrees rotation. Now we know that 180 degrees rotation is basically multiplying something with minus 1. That means multiplying something with minus 1 is equivalent to multiplying something with I square, I into I. So that means I square equals to 1, which leads us to I square minus 1, which leads us to I being the square root of minus 1. So this is where your definition of imaginary number stands. I, the imaginary number, is square root of minus 1.